Okay, so in this video, I'm going to work out a problem that requires us to find the derivative of the function y equal to x to the power x. And of course, I'm going to use two methods. So I think I should point out two things. So I'm going to use two methods, and one method. So of course, somehow all the methods will use the facts that I've listed in advance. So these are the facts that I'm going to use. So one fact is that the natural log and the exponential function are inverses of each other. And one thing that comes out if functions are inverses of each other is such a thing that happens when we compose two functions. So if I input x in the natural log and then I take the exponential, I get back to x. Or if I firstly take okay, so if I firstly take the exponential of x and then I take the natural log, I get back to x. So those two things happen when functions are inverses of each other. And using these facts, I can deduce that any general exponential function, for example, a to the power x, can be written as e to the power natural log of a to the power x. So what I've done is just replace this x and this x with a to the power x. And according to the laws of indices, when I'm dealing with the natural log of a to the power x, I can bring the x forward, and this is what I have. And then I'm also going to use the fact that if I differentiate an exponential function of x with respect to x, I get e to the power x. But then if the function on top is a function dependent on x, then I'm going to use a chain rule, and this is how it works. And then the other fact that I'm going to use is the derivative of the natural log of x is 1 over x. And then when the function inside the natural log is given in terms of x and not just x, then I'll use a chain rule, and this is how it works. So let me start with method number one. So method number one. So the very first thing that I'll do is that using this fact, I know that x to the power x, we know that x to the power x can also be written as e to the power natural log of x to the power x. And of course, that gives me something like this. And that's how else I can write x to the power x. So x to the power x is the same as e to the power x natural log of x. So if I want to get dy dx, which happens to be the derivative of x to the power x with respect to x, then I'll just be differentiating the function e to the power x natural log of x. Now, at least this looks familiar. At least I know how I can differentiate the natural exponential function, where the function on top is also dependent on u. So what I'm going to get is that I'll have e to the power x natural log of x, and then the next thing to do is that I have to differentiate the function on top as well with respect to x. And for me to differentiate this one, I'll use, for me to differentiate this function, I'll use the product rule. And this is what the product rule says. I'll differentiate x first and leave natural log of x intact. So differentiating x with respect to x gives me 1, and then I have natural log of x. And then plus, I'll leave the x intact, and then I'll differentiate natural log of x. And using this fact, the derivative of natural log of x is 1 over x. And what I get as the answer is this, natural log of x plus 1. But at least I know that e to the power x natural log of x is the same as x to the power x. At least we deduced it from this. And the whole expression will read x to the power x times the natural log of x plus 1. And that's the answer. Now, I'll also use method 2. I think you can choose whichever method you're comfortable with. So method 2 uses the idea of implicit differentiation. And how this goes is that if I have y equal to x to the power x, I can take the natural log on both sides, and I have natural log of y, natural log of x to the power x. And the right hand side will give me x times natural log of x. And for me to get dy dx, so hence we can have it that to get dy dx, or the derivative of y with respect to x, I have to differentiate on both sides of this equation. So differentiating on the left, so differentiating the natural log function, I get 1 over the thing inside. And then since y is a function of x, I also have to use chain rule, then I'll have to differentiate y with respect to x. And then differentiating the right hand side with respect to x, I have to use the product rule. So how the product rule works is as done previously. So I'll start differentiating x with respect to x. I'll get 1, then times natural log of x. And then I'll differentiate x. No, I'll differentiate natural log of x with respect to x. I get 1 over x, and what I get is the same expression like I had before. And that's 1 over y dy dx. And for me to get dy dx, I just need to make it the subject of the formula. And dy dx will simply be y times natural log of x plus 1. But y is x to the power x. And that becomes x to the power x times natural log of x plus 1.